In this video, we shall look at some basic vector operations. Let's look at the following problem. You are given these three vectors, vector A, vector B, and vector C. They are expressed in terms of unit vectors I hat, j hat, and k hat. You are to perform these vector operations and determine the results. So let's do the first one. Vector A plus vector B. Vector A is given by that and B is given by that. So A plus B means 3i hat plus 2j hat minus k hat plus vector B, which is 2i hat minus j hat plus k hat. So of course the rule is I will go with I, j with j, and k with k. So 3i plus 2i, that's going to give you 5i or 5i hat. 2j will go with j, so 2j minus j, so that is 1j or 1j hat, minus k hat plus k hat, and that is 0. So that is the answer for A plus B. Now let's do vector B minus vector C. So vector B minus vector C equivalent to, let's look at what B is. B is 2i hat minus j hat plus k hat minus, vector C is the third vector, I hat plus 3j hat. So again, this is something like a sum operation. So 2i hat minus I hat, so that is I hat, minus j hat minus 3j hat, so that is minus 4j hat. And here you have k, and over there is no k, or you can assume it is 0k hat. So plus k hat minus 0k hat is just plus 1k hat. So there we have it. This vector here is the result of subtracting C from B. Next, A sub x. That means the x component of vector A. So vector A is given by that expression. So the x component is the number that multiplies the unit vector I hat, because I hat is the unit vector along the x-axis. J hat is the unit vector along the y-axis, and k hat is the unit vector along the z-axis. So the number that multiplies the unit vector along the x-axis is the x component of that vector. So in this case, ax is quite simply 3. Likewise, by is the y component of vector b. So the number that multiplies j hat is minus 1. So the answer there is minus 1. And finally, cz, or the z component of vector c. You see that in the description of vector c, there is no k hat, or quite simply it is 0 k hat. So that means the z component of vector c is just 0. Now let's do this operation right there. Now the first thing to do is A dot C. So vector A dotted into vector C. So we are performing a dot product. So that means 3i hat plus 2j hat minus k hat dotted into I hat plus 3j hat. Remember, there is no k hat, so you can simply write it as 0k hat. So how do we perform this dot product? Well, it's quite simple. I will go with I, j will go with j, k would go with k. Because any other dot product that is dot product among other unit vectors will quite simply result in 0. So 3i hat dotted into I hat is just 3. 2j hat dotted into 3j hat, that is 6. And this is a minus k hat dotted into 0 k hat, and that is just 0. So the answer for a dot product is just a number. In this case, it is 9. So A dot C is just 9. The next dot product that we need to do is between vector A and vector B. So let's do that. A dotted into B. So that means 3I hat plus 2J hat minus K hat dotted into 2I hat minus J hat plus K hat. So 3I goes with 2I, so that's going to give you a 6. 2J dotted into minus J, that's just minus 2. And minus K dotted with K, and that's going to give you minus 1. And what is the answer? 4 minus 1, that is just 3. So let's use these results to write down the full expression for that. A dot C is 9. To that you multiply vector B, which is 2I hat minus J hat plus K hat, minus A dot B, which is 3, times vector C, which is I hat plus 3J hat. So the answer to that is, so here you have 18I hat minus 3I hat, so that is 15I hat, and then you have 9 or minus 9J hat minus 9J hat, so that is minus 18J hat. As for K hat, you have 9K hat from the top minus 0K hat, so that is just 9K hat. And this is the result for that operation. Next, A dot C. So we have already worked this out earlier when we perform that operation, and then we said the answer was 9. So let's just write the answer there, and you will see that it's an important result later when we compute the angle between the two vectors A and C. So let's move on to the magnitude of vector A. So the magnitude of a vector is given in a following manner. So you look at this vector A, the components are 3, 2, and minus 1. So you have to square the components, sum them up. So in this case, the x component is 3, 3 squared, plus the y component is 2, so 2 squared. The z component is minus 1, so minus 1 squared, and then you take the square root. And that is the magnitude of vector A, which in this case will turn out to be square root of 14. Likewise, you can determine the magnitude of vector C. So the magnitude of vector C is the square root of the sum of square of its components. So the first component here is 1, so that's 1 squared, that's the x component of vector C. The y component of vector C is 3, so square that. There is no z component, so 0 squared, and that's going to give you a square root 10. Now let's look at how to calculate the angle between vector A and vector C. Now we can calculate this angle by using the definition of dot product. So the dot product between vector A and vector C is equivalent to magnitude of that vector A times the magnitude of vector C times cosine of the angle between them. So this is what you are looking for. A dot into C is 9. We have computed that earlier. The magnitude of vector A is square root 14. The magnitude of vector C is square root 10 cosine theta. And you see that theta can be calculated. And when you do that, you get theta to be 40.5 degrees. So that is the angle between vector A and vector C. Now the last operation. A cross C. So this is a vector product of A and C. So to do this, we can rely on the determinant method. So the first row is the component or the components of vector A. So in this case, the x component is 3, the y component is 2, and the z component is minus 1. Then the second row is occupied by the components of vector C. So the x component of vector C is 1, the y component is 3 and there is no z component, so that is just 0. So we are performing a vector product or a cross product, so the result is a vector. So to do that, let's do one by one. Let's cross out the I hat in two mutually perpendicular directions. So the result is a determinant, a 2 by 2 determinant, 2 minus 1, 3, 0. So the determinant is calculated by this times that, which is 0 minus that times that. So you get the x component of that result is 3, because 0 minus 3 is 3. Now let's do the y component of this product. So as part of the formula, you have to place the negative sign in front of that j hat, and you cross out the j hat in two mutually perpendicular directions, so you are left with 3 minus 1, 1, 0. So this times that is 0, and this times that is minus 1, so minus minus 1, and you get minus j hat. So that's the result for the y component of this cross product. So now we are left with the last component, namely the z component. So you cross out the k hat in two mutually perpendicular directions. So this times this is 9, so 9, minus this times that is 2, so minus 2. So that is going to give you 7k hat. So there you have it. The result of this cross product is quite simply 3i hat minus j hat plus 7k hat. As always, thank you for watching.